Hello, everybody, and welcome. How are you? So first, I'd like to welcome all of you to our session, which is an official collaboration with Math Kangaroo. This might feel a little different from some of the sessions that you've been in before, especially if you're joining us by Zoom or if you're joining us by YouTube. So I'd just like to first make sure that people are comfortable with the way that this system works. And then, of course, I'll do an introduction of what we're actually doing. So to use this system, if you happen to be in the Zoom meeting, please select to send a message to Chat Relay. So the way this works is that when you use Zoom chat, normally you can send it anywhere and it just fills the whole room with spam. But what we want to do here is we want to see if this works. You just inside your Zoom, just select to send a message to Chat Relay and the messages will appear here as long as they aren't totally inappropriate. And if you are watching from YouTube and if you don't know where the Zoom link is, that's also okay. There's another link. It's called live.poshenlow.com/show, which you can go to. And if you just type in live.poshenlow.com, live.poshenloh.com/show, you can also join in and comment all you wish. But regardless, that's how this works. It looks like we're here. I'm guessing that also means you can hear me. So then I won't ask you, can you hear me? Well, with that, let me go ahead and say what this is about. We're really, really thrilled to be collaborating officially with Math Kangaroo. And Math Kangaroo is a competition which is run all over the world. And in fact, one of the remarkable things about it is that the questions are really, really creative. In fact, I myself, I have to confess, when I was young, I didn't know about Math Kangaroo, so I didn't do the contest problems. But at some point later, when I found out what they were, I just remember smiling and saying, wow, these are actually really cute and really creative. So when I saw that, I said, we are really happy to do this collaboration. William, I can see that you're also happy that you did this. Fantastic, right? But so we're looking forward to doing this collaboration. In fact, we're going to be doing a live stream based on Math Kangaroo problems, officially collaborating with them every 2 weeks, every Friday, right here at this time. Now, the way this works, though, is it's not only me. In fact, if it was only me, that would only be marginally interesting. The reason this is so much more fun is because we're also going to be joined by some co-stars. And the co-stars that we have here are remarkable at mathematics also. They are, tonight, we have Alon and Aiden. I know them both from the fact that they did math counts. In fact, they were both at the top 4 of their states in these math counts competitions, which means they're really, really good because the states they came from are also Washington and Texas. But with that, let me toss it over to them so they can briefly introduce each other and then we'll jump in and start doing problems together. Aiden, why don't you go?
All right, okay, so I'll introduce Alon first. He is an amazing person. So first off, in his math career, he's qualified for AME 3 times. That means he's basically been in the top 5% of AMC test takers 3 times. He was also Math Counts Nationals and Washington team, just as Professor Lowe said. Besides that, he also played piano for 8 years, which is definitely really a lot of perseverance.
Yeah, hello everyone, I'm Alon, and I'm so happy to be here with my co-host, Aiden. He got to honorable mention in USA JMO, which is just crazy hard. He also got into Math Counts Nationals from Texas, which is another really competitive state. And besides math, he also plays basketball on his school team.
Awesome, so who's ready for some Math Kangaroo?
All right, let's do this. Okay, so what we're going to do here is we're just going to take turns. And there's 3 of us, so we're just going to take turns going through problems. I guess I'll jump in first. And these are questions from the grade 9 to 10 from Math Kangaroo. Again, these are all used with permission with Math Kangaroo USA, with which we're officially collaborating here. And thanks to everyone for participating in the chat. We want this to be as engaging as possible. Please just talk. This is not like your usual class, unless you take class with us, in which it is exactly like your usual class. But let's keep on going. So what is this question? Carolyn is forming the 4-digit number 2022. I'm guessing this was a 2022 problem. Okay, forming this 4-digit number 2022 using some matches from a box. The box originally contained 30 matches. She has already started and formed the first 2 digits, 2, 0, as shown in the diagram. How many matches will remain in the box when she has finished forming 2022? Okay, I hope I get this right, because I think this shouldn't be too bad. So let's see. So how many matches are in the 2? 1, 2, 3, 4, 5. And I'm checking in my head, that actually makes sense from an even or odd perspective, because it's like, that's how I check to make sure I don't make a mistake. I see those 2 pair up, and then that's adding with something that doesn't pair up. So there's 5 here. By the way, co-hosts, if I screw up, help correct me. So here's 5. This thing's actually going to be an even number. So that's 2, 4, 6. There's 6 here. So if I want 2022, I guess it's 5 plus 6 plus 5 plus 5 is going to be the number of matches for the 2022. Okay, and then I think I'm going to subtract down from, how many are there altogether? 30. I think people are possibly going to tell us the answer too. Feel free to type the answer to get it. But so I've got 30 minus this. So my answer is going to be 30 minus this. I guess the way I'm going to add them up is that I have, this is basically 20. It's like 20 plus 1, like 4 5s makes it 20. So that's 21. And if I subtract, I think that's 9. So I hope that's the answer. Let's find out. Oh yeah, here's how I go forward. Let's find out. Yay! Okay, I can do one question. I did problem 1. Let's toss it back to Aiden. Why don't you take the next one?
Awesome. All right, so the next question. Katrin or Katrin, someone arranges tables of size 2 times 1 rectangles according to the number of participants in the meeting. The diagrams show a top view of the tables for a small, right here, medium, and a large meeting. How many tables are there for the large meeting? So basically what we're doing is we're just taking these rectangle things and putting them along the border. And our question is, how many in the 7? So I noticed there's some sort of symmetry here. In each of these squares, we can split it up into 4 basically equal parts. For example, in the medium here, that'd be these 4 rectangles, each of them with 2. So if we split this large screen up, we'll also have 4 equal sized parts. The only difference here is that it's a little bigger. So this is 7. So right here, that would be 1. So right here, we can put a total of 6 lengths. 2 times 1, 6 divided by 2. That means there's going to be 3 rectangles in each of these 4 segments. So of course, 3 times 4, that gives me 12. So I think the answer here is answer choice C. All right, let's see if this is correct. Awesome. Okay, I'll toss it to Alone now.
Yeah, okay. Oh, and this problem is kind of covering me out a little bit, so I'll move it over here. Okay, so in the rectangle shown, the midpoints of the 2 longer sides are joined to all 4 vertices. What fraction of the rectangle is shaded? Okay, so I see we have lots of these like triangles, but we want to like split this up a little bit better. So why don't we like draw this line in the middle, and that will split it up much more nicely into a lot of smaller triangles. Okay, but wait a minute. All of these triangles are the same. Well, hold on, no, not exactly. This triangle and this triangle are the same, and this triangle and this triangle are the same. Okay, but what about like all of these triangles? Oh, that's a bit tricky actually. What if we, okay, so we're only looking at the fraction of the rectangle that is shaded. So what we can do here is we can assume that this is 1, that is 1, and that is 1, because we only care about the fraction. So we can like assume all of these lengths are nice, convenient lengths for us to calculate things on. Okay, if that is true, then this length, the height essentially of this triangle is 1/2, because it's literally just half of this. And the base is 1. So the area of that triangle is going to be 1 times 1/2, and then times 1/2 again, because that's the area of a triangle. And that gives you 1/4 for the area of one triangle. But we have 2 triangles. So that means that the area of the shaded region is 1/4 times 2 equals 1/2. Not exactly. Because actually, what's happening here is that the whole rectangle has area 2. So the fraction of the shaded area is 1/2 divided by 2, or 1/4. Therefore, I think the answer should be B. Let's find out. Yeah, okay. Great.
Terrific. Okay, I guess it's my turn. Let me advance. Okay, what do we have here? I guess people like geometry. Actually, we always ask other people to help us choose the problems, because in case you didn't know, the three of us haven't done these problems before. And so we're just trying to figure them out as we go. And by the way, if you just joined the stream, just so you know, the way that you can join this lively chat is that if you're inside the Zoom meeting that we're all in, please just send a message to chat relay, and then your wonderful words will appear here. And if you're watching through YouTube and not through Zoom, there's actually a URL. There's a particular website you can go to, live.poshenlo.com/show, where you can enter all the comments that you want as well, and they'll appear right here. We actually are not looking at the YouTube live chat, so whatever you're talking about there, unfortunately, we won't see. All right, let's do this. 5 squares and 2 right triangles are arranged as shown. The numbers 3, 8, and 22 inside 3 of the squares indicate their areas in square meters. What is the area of the square containing the question mark? Oh, okay, this is cute. I like this. This is the Pythagorean theorem. So by the way, whenever I look at questions, what I mean by something is creative is it's not just telling you use a squared plus b squared equals c squared. However, when you think about the Pythagorean theorem, in fact, if one side is a and one side is b and one side is c, well, a squared is the area of that square. Those are squares. Yes, those are squares. So the area of this square, a squared, is equal to 3. So I have a squared is equal to 3, and I have b squared is equal to 22. So that means that c squared is going to be 3 plus 22. So c squared is going to be 3 plus 22, which is 25. But then the exact same thing is going to happen on the other side, right? Because like over here, I guess I don't have a, b, and c anymore. Well, I do still have c, I guess. I still have c. But I guess they should be called something else. Maybe they should be called d and e. And the Pythagorean theorem will now tell me d squared plus e squared is equal to c squared, right? And now the c squared is the 25. We can do the same thing again. That means that the 8 plus the something is the 25. So the question mark is going to be equal to 25 minus 8. And that's 17. Is there a 17? Is this right? Let's see. I see that some people who are participating in the chat think it's D also. Yay, we passed. Aiden, on to you.
Awesome. Oh my gosh, this was a really cool problem. I loved how instead of using our normal algebra, we transformed the question into geometry. Square plus square equals square. That's awesome. All right, next question. Okay. I once met 6 siblings whose ages were 6 consecutive whole numbers. Consecutive means they're just +1, +1, and +1. I asked each of them the question, how old is your oldest sibling? Which of the following could not be the sum of their 6 answers? Okay, this doesn't really seem like a lot of information. The only number we have here is 6. So that will definitely be important. Let's dive in here a little bit more. So suppose we had 6 siblings. I'll just draw stick figures right here. 4, 5, and 6. And one of them's the oldest. You ask each of them, how old is your oldest sibling? Well, the oldest sibling in the family is a little bit special. If we look at anyone else, suppose we look at the youngest sibling will always say the oldest sibling, that age will be my oldest sibling. So if this one is the oldest, the other 5 will all be saying the same age, which is this person's age. Let's call that age X. Now, for the oldest sibling, it's a little bit different because he himself is not his own sibling. He's talking about his next oldest sibling. And here's where the consecutive number part comes in. Consecutive whole numbers. Because he's the oldest, the next oldest will be exactly a year younger than him at age X minus 1. So now the question talks about the sum. So we sum all this up. That would be 6x minus 1. What this means is that the sum of these responses is always 1 less than a multiple of 6. And now we just have to go through our answer choices and check these answers plus 1 and make sure they're a multiple of 6. So 95, is it 1 less than a multiple of 6? Yes, because 96 is a multiple of 6. 125, let's look at 126. Also a multiple of 6. Next one, 168. That's also a multiple of 6. One way we could do this is, remember, the divisibility rule for 6. It has to be even, and it has to be a multiple of 3. So the first criteria is checking if it's even. The next criteria is looking at the sum of the digits for them to be a multiple of 3. Okay, so far we're all good. And now for D, 206. Is this a multiple of 6? No, because this is not divisible by 3. Therefore, D cannot be one of their answers. And just to be safe, I'll check E real quick. 234, even, sum of digits is 9, we're good. So my answer is D. And let's check it. Awesome. On to you, Alon.
All right. Yeah, that was a great problem, I think. A nice mix of logic and number theory. I loved it. Okay, but let's go on to the next problem. So yeah. Oh no, it's so rudely covering my face again. I have to move it aside. Okay, the diagram shows a large rectangle ABCD divided into 12 identical small rectangles. What is the ratio of AD to DC? Interesting. Okay, I think I see a lot of like lengths here. And I think one really important thing to see here is this length goes across the entire thing. So what we can see here is that this length is composed of 2 large lengths and 3 small lengths. Okay, I think now it's a good time to set some variables. So if we have one of these small rectangles that, 12 of these make up one bigger ABCD rectangle, we're going to let the long side be x and the short side be y. Okay, so now what this means is that this whole length is 2x. But it's also 3y because we have 3 short segments here as well. Therefore, 2x equals 3y. Perfect. Okay, what do we want to find? Well, we want to find AD to DC. So AD is going to be 2x plus y, which is actually also equal to 3y plus y, or 4y. And you can see it's 4y actually by just looking at these rectangles. So you have one short length, another short length, another short length, and another short length. So all of AD is really just 4y. And now CD, on the other hand, is going to be 3x. So essentially, what we want to find here is 4y over 3x. Okay, well, what is y over x? We can see over here, in fact, that 2 over 3 equals y over x, because you can divide by x from both sides and divide by 3 from both sides. So this we can split apart into 4 over 3 times y over x, which is really just 4 over 3 times 2 over 3. And that is equal to 8 over 9. So I think the answer should be 8 over 9. Let's see if I'm right. And I was right. All right, Press love, back to you.
Wow, this is great. Also, as we do all of this, I'm envying you guys' setups. Your setups look so much more interesting than mine now. This is how I started doing all of the live streaming during the pandemic. But clearly, the next generation always has much better taste. But anyway, we got to deal with this. Let's keep going. So the next question is, oh, this is interesting. So we have 3 paths. There are 3 paths through our city park. A tree is planted in the middle of the park as shown. What is the smallest number of trees that need to be planted so that there is the same number of trees on both sides of each of the paths? So if you've watched our live streams before, I think we actually did a question sort of like this. And that's because on Math Kangaroo, we actually have, well, not we, Math Kangaroo, they have questions which are at many different grade levels. So it's possible that their questions might match between, they might have the same questions used on different grade levels on different contests. So it could be this is the same. But I'm going to do it anyway, just because it could also be different. Because sometimes when contests do that and reuse the same problem idea, sometimes the harder contest has like another twist. So let's go and see. Let's try it. And of course, if you've seen this before, you're welcome to see if you can do it again too. So let's see. We need to have the same number of trees on both sides of the paths. And what's the star? Why are there stars? What's the smallest number of trees that need to be planted? This still looks different. So, okay, there's one tree. Oh, this is a different problem. I think this is actually different. So I seem to remember we did something, but we did something which was a much simpler version of this. So let's see. I need the same number of trees, and there's one already. Oh, wow. I actually have to think. And why are there some random stars? That I don't understand, but that's okay. So let's see. On both sides of each of the paths. So at that point, I see that I already will need to do something opposite each path. The easiest answer would be if I can plant one tree and I'm all good, but that's not going to be likely because I can't make all of them happy at the same time. Wow, I'm actually going to have to think about this. That's why I like these questions. They're creative. So if I want to have another tree on the opposite side of path 1, and on the opposite side of path 2. And okay, I see one way we could do it. So if I put one tree, I can't, my art skills are not as good as Aiden's. Aiden draws great people, but my trees are this, okay? So this is a tree. This is a tree. I think I can get 3. I want to see, that's like, so that tree has been hit by a hurricane. But anyway, so let's see. Is there one? Oh, no. This looks all messed up. I was going to say, I want to balance that one. But that's not okay. Because I was trying to balance that one, which is here, by putting one on that side, one on that side, and one on that side. But unfortunately, that's not going to solve it either. Oh boy. I feel like, should I write equations? That looks problematic too. See, the easiest way to solve this is just to cut down the tree at D. But I'm afraid -1 is not an answer. What else can I do? Same number on both sides of each of the paths. What if I write some equations? I'm actually just curious what's going to happen. Usually there's a bigger picture with more space here. Yes, I got all these pictures with more space. So let me see. So if I just try to write equations, I have A plus B plus E is equal to C plus D is 1. I don't think there's ever going to be any point in making more trees there. So plus D plus G plus F. Oh. There's an F before a G. Okay, that's for equation 1. Equation 2, this is not nice either. I was hoping I'd get some kind of canceling, but I can't do that either. So in that case, I'm going to go back and I'm just going to say, if I'm trying to balance this, I'm going to try a greedy algorithm. I'm going to try to balance this by trying to put the trees in places that they will help me balance things more. So let me first attempt to balance path 1. To balance path 1, I need to put something on the other side. And I learned my lesson last time when I stuck it like up there or something, or up there. I made path 2 even more unbalanced because path 2 would then get 2 trees up there. So that tells me maybe if I stick a tree over here in E, life would be happy. Let's see. So if I put the tree in E, suddenly path 1 is balanced because there's something on each side, and path 2 is also balanced because I've got one on each side. And there's just this annoying path 3. That is really annoying. I mean, I see that I could fix it by putting 2 more trees, and if I put 2 more trees, if I do one here and one here, I think I managed to balance path 1 and path 2. So I can do it with 4, okay? But the question says, how few can you do it with? Okay. So now I'm going to start to go upwards and see if I can do it with fewer than that. But first I want to just double check. Can I do this? Is this legit with 4? Like path 1, it's got like 2 and 2. Okay, and path 2, it's got this way, which is also 2 up and 2 down. Good. And path 3 is 2 and 2. So that's interesting. Ooh, I just figured out that the answer has to be that the total number of trees has to be even. Because like if I look at any one of the paths, the number of trees on each side has to be equal. This sounds useful. Total number of trees has to be even, right? Because otherwise I would never be able to have the left side equals to the right side. That's very powerful because that means the total number of trees is either 1 or the total number of trees is, no, I mean, sorry, I already went one step ahead. The total number of trees is either 2 or 4. Everyone okay with that? Like, please enter in the chat if you're following what I'm saying. Like, because I'm trying to say like, there's all these answer choices. It looks kind of problematic, but so far it looks like I don't have to worry about too many because I can't have an odd number of trees and an equal number on each side of a path. So it's either 2 total or 4 total. Here's the 4 total. Wait, what did I do? No, I even screwed up. It's not 4. I can't subtract. I meant 3. Okay. So what I meant is like, this is a total number of trees, which is 4 total. Yeah, 4 total. Did I do that right? Yeah, it's 4 total trees. I have 4 total trees here, which 4 minus 1 is 3. Okay. So far C is an option. And the answer is it's either C or A. Oh, but come on, it can't possibly be A. Like, A just doesn't look possible. How can I plant 1 tree and satisfy all of these? Is there a way I can explain how that is impossible? Let's see. Well, it just looks pretty impossible. If I wanted to put 1 tree down and balance path 1, yeah, I think I know how. Because like we actually saw that. Yeah, I love how some people are saying A is small. The warrior cat said A is small. It's just too small. And I know that because the way I came up with this spot to put E was that was the only place I could put a tree to balance both the path 1 and the path 2 at the same time. Because anywhere else that I put it, I will have like not equal on both sides of path 1 and path 2. You see, if I want to balance path 1, I need to put something. Well, let's use the next picture. If I want to balance path 1, I have to put a tree somewhere here because there's already a tree on this side of path 1. If I want to balance, hey, whoever drew this picture, thanks. It's exactly how many pictures I need. If I want to balance path 2, I need to put a tree somewhere there because I already got 1 up there. So it's got to be 1 on the other side. Therefore, if I want to balance both 1 and 2, both paths 1 and 2 with just 1 tree, the only way to do it is to stick 1 tree in the intersection E. And we saw, oh no, we're dead because we got to put 2 more there. So that's how I know I need to have, I can't do it with just 1 more tree. I can't do it with just 2 total. So I'm going for C. I wonder if that's right. Bam! Okay, this works. And this was a really cool problem. Okay. Do my co-hosts want to add anything on this?
These problems, they really get down on my nerves because you never know if your answer is really the smallest until you go really far to prove it. And luckily, we could prove it here. But other times when it's like, is it this or is there something smaller? That's really nerve-wracking. But keep trying.
I want to add here that this kind of shows you why 3 looks as if it's like the most optimal, because you have like the intersections here at this section, and this section, which you can't see the letters, but they are sections A, E, and F, I think it was. I forgot. Yeah, these 3 sections basically. And those ones are all in the same, each of those sections are in 2 different of these. So like you have yellow, you have blue, and you have red. And each of those colors are a different area that you have to put in a tree to balance the line. And so if you put 1 in all of those 3, that will balance all of the lines. So yeah, that kind of explains why it's 3 and why 1 does not work.
Wow, cool. Thanks a lot. That's great. Let's pass this to Aiden to go on to the next one.
All right. Anyways, I must say, Professor Lowe, you're really good at drawing trees that got hit by hurricanes. All right. Anyways.
Awesome.
Next question. 8 teams participate in a football tournament. Wow. Okay, that's amazing. 2 amazing things: football and math. Let's keep going. Each team plays each other exactly once. That must be important. Plays each other exactly once. And in each match, the winner earns 3 points and the loser does not earn any points. If the match is a draw, each team earns 1 point. At the end of this tournament, the total number of points earned by all the teams is 61. Oh, okay, this is similar to a previous question. So we're summing everything up again. Summing everything up, and we get 61. That's important. That's a number right there. What is the largest number of points that the championship team could have earned? So largest number of points. This makes me a little bit nervous because there's not a definite answer. We're actually trying to find the largest possible way. Let's see what we can do here. So if there's a winner and a loser, then the winner gets 3 points and the loser gets 0 points. If it's a draw, they both get 1 point. Now, I wonder how we can relate this to the sum of the total points, because clearly every time a team plays each other, there's going to be some difference in the total amount of points earned by all of them. For example, if the tournament just started and one team just won, so I don't know, maybe this team is the happy face team, and then this team's the sad face team, and then the happy face team won. That's the first game in the tournament. Then the total sum of all the points for all the teams will go to 3. On the other hand, if we focus again on just these two teams, if they drew, then the total sum of all the points will be 2. That's interesting. So instead of looking at the big picture, all we really needed to do was just start zooming in a little bit. We zoomed in on one game, and we learned if one team wins or another team loses, the counter for the total amount of points increases by 3. On the other hand, if they draw, it only increases by 2. Now that's interesting. Now let's think about everything. I think this is a good place to use variables because we don't know how many teams won and we don't know how many teams drew or how many games happened. There's a lot of things. So 2 things we want to know. How many sets of games had a winner? That must be important. And how many sets of games had a draw? And then if we add these up, then we get the total amount of games. All right. Now we can start working on this. So I will set how many sets had a winner to be W, how many games had a winner. And then how many games had a draw, I'll call that D amount of games. So using the number 61 here, we can write our first equation. Our goal is 2. We have 2 variables. So for a winning set, 3 times the number of games with a winner, that means 3 points per game with a winner, plus 2D, 2 points per game with a draw. Sum that all up, 61 points at the end. Now we need another equation because 1 is not enough. So let's return to our original question. So we use the number 61. We use the number 1. We use the number 3. Actually, there's one more number here, and they made it a word. So 8 teams. That was a little mean. 8 teams. How do we use that number? So if we have 8 teams in a football tournament, and again, we zoom down only thinking like 8 teams, we can actually figure out how many games they will play. Remember, they play each other exactly once. So for example, if we had team 1, team 2, team 3, team 4, no stick figures this time, sadly, team 7 and team 8, and we're playing football, then some of y'all might know 8 choose 2 to be how many games between all of these if they play each other exactly once. You're just choosing 2 of them and then making them play a game. So this is 8 times 7 over 2, which is 28. If you don't know this notation, that's all right as well. Just think about it this way. Team 1 will play all the teams exactly once. So all games involving Team 1, there's 7 of them. And now all the games involving Team 1, we already counted. So I'm just going to get rid of that. It's gone from what we count. Same thing for Team 2. 6, and then we get rid of that. We counted that already. And so on. 5, 4, 3, 2, 1, which also sums to 28. So there have been 28 games. That's good for us. W is the games with the winner, D is the games with the draw. So W plus D is the total games, 28. These are our equations. And now all we have to do is solve it. Multiply this equation by 2. 2W plus 2D is equal to 56. Subtract this from down here, then we would get W is equal to 5. 5 games had winner. And of course, we could also find D is equal to 23 from here. Dang, that's a lot of draws. Anyways, back to the question. Remember, what we want is the largest number of points the championship team could have earned. So remember, 23 draw games, and then 5 with wins. Now, for a championship team, in order to get the largest number of points, we want them to have all the wins for sure. One championship team, they play 7 games against all the other football teams. So if 5 of those games are wins, they get 5 times 3, and then, well, we'll have to use up some of the draws. So then 1 plus 1 for the other 2 games. Sum that up, that's 17. So this should be the largest amount of points the championship team can earn. My answer is D. And let's see what Math Kangaroo's answer is. Also D. Okay, actually this problem is very impractical. I don't think you see a lot of draws in football, but mathematicians don't really care about that. We just care about, I don't know, 28 games, 61 wins, all the numbers.
Yeah, these people are very peaceful.
Yeah, they are. All right. Okay, this time the question did not cover my face, which is quite nice. But yeah, let's go on to this one. The inhabitants of a certain city always speak by the means of questions. There are 2 types of inhabitants, the positives, who always ask questions for which the answer is yes, and the negatives, who always ask questions for which the answer is no. I met Albert and Berta. Berta asked me, are Albert and I both negative? Well, what? Wait, what? What type of inhabitants are Albert and Berta? Okay, this is quite confusing. Okay, let's try this out. So A and B. If Albert is a positive and Berta is a positive, so Berta asks me, are Albert and I both negative? If they're both positive, then the answer to that is no. And in that case, that would be false. And we know that Berta always has to ask questions for which the answer is yes. So that would be not possible. So we can cross that one off. What if Albert was a positive and Berta was negative? Okay, well, for that one, the answer to this question, are Albert and I both negative, is actually no. And that's because they're not both negative. So again, we know that Berta needs to ask questions that are always no. So in this case, that should work. Okay, let's leave this. Let's circle it so we know it works. But I can see over here that there is an option that says there is not enough info to decide. So we might need to come back to it later on. Let's see. What if Albert is negative and Berta is a positive? In that case, Berta needs to always ask questions for which the answer is yes. But in this case, actually, the answer should be no, because Albert is negative and Berta is a positive. And so in that case, they're not both negative. So this one is impossible. And finally, if they're both negative, then, oh, that's pretty easy actually. In this case, the answer is yes, but Berta is negative. So her questions need to always be no, but because the answer to this question is a yes, this needs to be impossible. Therefore, we get that the answer is Albert is a positive and Berta is a negative. Okay, wow. There were like a lot of different yeses and nos here. There was like positive, negative, answer to the question is yes or no, and then whether or not the actual thing is possible or impossible. But I think we figured it out. It should be C. Let's find out. Yeah. Okay.
Wow.
Wow.
Wow. Oh my gosh. So these types of questions, sometimes they're annoying, but they're also awesome. It's like you're having a Muppet show in your head. It's like, wow, okay, I'm a positive. I always speak the truth. And then, oh no, I'm not a negative. I never speak the truth. And you're just having fun with those Muppets. Which one's doing what? That's up to your brain to decide.
Yeah, that's pretty interesting. I mean, at the beginning when I saw this, I mean, our team, we can see each other sometimes because we are in this internal Zoom meeting. So when I saw this question, I was doing like this. I was like, oh no. And then that's because I was like, how do you simulate this Muppet show that Aiden was just talking about? But yeah, it worked. Okay, I guess we have this next question then. Question 28. And our team tells me that that's the last question we have. So let's see how this goes. The positive integer n is such that the product of its digits is 20. It's a very short problem. Which of the following could not be the product of the digits of n plus 1? Not be the product of the digits. Okay, well, I'm going to look at these answers first and say, is there any pattern about them? Okay, hard to say. I was wondering if I can just get an easy answer to this, but maybe not. All right, so if I want to know what could not be the product, I need to rule out things that are the product, right? So let's just go ahead and start. Could I get a 40 made of multiplying the digits of n plus 1? Well, 40 is like, that's, oh, wow, this is interesting. Oh, this is neat. If I have something which is a 2 and I change it to a 1, that's like a way to get, all right, here's an idea. I could have something like the number n is like blah, 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 1. And then the number n plus 1 would be the number blah, 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 2. So now what that means is, well, I mean, I'm sure there's some way to get a number where the product of the digits is 20. If I have the product of those digits is 20, like 451, for example, then 452, that's going to give me the 40, right? So it is possible, and I'll even write the example. If I had 451 and 452, then I'm able to get the answer choice A. And that's because 4 times 5 times 2, that's the 40. And this way of thinking now tells me something about, let's look at ratios. Like if I want a 30, and if I want a 30 to come from an n plus 1, and I want that the n is a 20, do I know any good choices of last digits that would give me a ratio where I go from 20 to 30? You can type in the chat so we're a little bit more interactive, right? If my product before was 20 and my new product is 30, what am I trying to do? I'm trying to multiply by 3 over 2. But I could do that. I could do that if, for example, I had the number n was ending in a 2, and then the number n plus 1 would end in a 3, right? And by the way, I can make something end in 2 by just saying I need the product of the digits is 20, so I need the product of these digits to be 10. 2 times 5? Yeah, like 252 and 253. It's actually not important to write these exact number examples down, but I'm just going to do it to make it as understandable as possible to people who are watching this live stream. So that's a no. 25. Oh, I see. I get it. So 25 comes 2. Like, so can anyone type into the chat, please, so that we're having it a bit more interactive? But what can I do to make a 25? If I had something that was 20 before, it ends in some digit, and then I want it to end in the next digit, and that should boost me from 20 to 25. Yes, I see people putting this into the chat. Thank you very much. Liv, I see that you put 4 goes to 5. That will also do it, right? So if I had n being some number which ends in a 4, and n plus 1 being some number that ends in a 5, that's going to give you from 20 to 25, assuming it's possible to make a number whose product of digits is 20, where the last one's 4. But that is 54. And 54 to 55. Okay, so that one's dead. How about C? How about D? Can I go to 35? 20 goes to 35. Now I've already got this idea. It's got to be like the last digit playing around, right? So the common factor between 20 and 35, that's a 5. So it's 5 times 4, 5 times 7. I can't go from 4 to 7. So I'm a little suspicious of D. Let me look at E. Oh, E is good. Because from 20 to 24, can anyone tell me? I already see answers coming in. So from 20 to 24, yes, Rohan, that's right. 5 to 6, that's how I would do it. If I wanted to go from D to, if I wanted the thing in the E, if my N ended in a 5, and then my N plus 1 ended in a 6, well, that would work. Assuming that there is a way to make something ending in 5, which is a product of digits 20, and there is, it's 45. 45 going to 46, that would do the job. And by process of elimination, I think the answer is D. Let's see. Yay, it is. Do my co-hosts have something to add? I saw that Alon's writing something.
Oh yeah, so I just wrote down some more of my own examples. You have like 541 for A, which goes to 542. You have 522, which goes to 523 for B. You have 514, which goes to 515 for D, and for C, and you have 415, which goes to 416 for E. And with that, you only have D left. So yeah, that works.
Oh, I also wanted to say, so, math teachers, they like playing which of the numbers don't belong. And I was just saying, okay, what if a math teacher was like, hey guys, so our warm-up for today is which of these numbers do not belong? I'm guessing that most of the amazing math students will immediately notice 0, 0, 5, 5. These are all multiples of 5. And so maybe 99% of people will say, okay, 24 doesn't belong. Or maybe some, I don't know, other amazing people will also say 25 doesn't belong because it's the only perfect square. But now we have something epic for y'all to say, thanks to Math Kangaroo. You can say that 35 doesn't belong because it's the only positive integer such that the product of n minus 1 is 20, and it cannot be the product of the digits of the next number. So that's awesome.
That's incredible, Aiden. That's a great spin to put on it. Of like, it reminds me of like sometimes a long time ago, I'd be like, here's a pattern, but I don't know how I can define a pattern to like make these numbers a pattern. And so what you've just done here is you've been like, how do I make it so that that number doesn't belong? Okay, so we actually, on the problems that we had for today that we isolated from Math Kangaroo, we've actually gone through all of the problems. Let me just mention something here. If you happen to like this, we're going to be having this every 2 weeks. And so these are actually how you can continue to follow this if you're interested. In fact, the next live solve at this level, which is grades 9 to 10, that's going to be in 8 weeks. So that's September 23rd. That feels like forever from now, to be honest. But I guess that's going to be like forever because school have started. But if you join us in 2 weeks, what you're going to see is a different level. I think we're going to end up doing grades 7 to 8 in 2 weeks. So basically every 2 weeks we'll have something on this channel. If you like this kind of stuff and want to stay updated, we have a newsletter. If you just scan this QR code, you'll be able to join our newsletter and we'll tell you whenever something like this is happening. And this is just a very big QR code for that page, which is how you can go and get to the Math Kangaroo thing anytime. And that one will always be talking about when will the next Math Kangaroo live solves like this be. Now, I see that some people are going to come, which is cool, but we got a few more minutes. So I just wanted to offer, whenever we finish early, if people have any random questions you want to ask, you're welcome to ask them. They could be about like math things. They could be about learning math. We have some remarkable people on this show with me right now, Alon and Aiden. And so if any of you have questions, we're happy to spend the last few minutes just answering anything you have, or else we'll just sign off. And if you are in this show, if you're in the Zoom meeting, the way you can talk is you just send a message to chat relay, and then your message will appear and we'll see it. And if you are joining through the internet another way, if you go to live.poshenlo.com/show, then you can also type in your comments. Ooh, we got some questions already. We have some high school students here too. Any of you want to take these?
I saw one that asked tips for Hmmt. So I've only done Hmmt one time actually. That was this year. I did the February contest there, through Washington Gold. And I'd say, okay, so Hmmt is a very interesting format. And so the way it works is you have like a team contest, and this team contest has 10 proof problems you have to solve in, I think it was 60 minutes as a team. So that is a really short time limit for 10 proof problems. And they're not like long proof problems. Like I'd say most of the proofs don't take too long to write up, but like you still got to make sure you budget your time correctly and that you practice with your team to make sure that like you all synchronize well together and that you all can divide up problems really quickly. So I wouldn't say that you should divide up the problems like beforehand, because I know some teams do that. They say, okay, this person gets one, this person gets two, and so on. I'd say you should do it really fast, like in a minute in the beginning, because a lot of people have different strengths. Like I am a really big combo person, so I would be able to solve like, I don't know, problem 5 or 6 if it was a combo. But if you gave me problem 1 that was geometry, I would probably struggle with it for like 10 minutes and then just give up on it. Because I'm just not good at geometry. So that's how it is. But yeah, so definitely use this to your strengths and not just like I'm taking problem 1, you take problem 2, you take problem 3, and so on. And then for guts is hard, but it just requires a lot of practice. I don't know how to say it in any other way. It's like a really fast-paced round, and there's no way to practice for it other than just doing past guts rounds and simulating it in time. So yeah.
Oh yeah, okay. I saw a question from Rohan. He asked Aiden, how did you find Amy qualification and USA JMO qual? Okay, number one, you spelled my name wrong. It's Aiden, but it's fine. I don't mind. Okay, I'm not exactly sure what you mean by find, but if you're asking for how to Amy qualify and how to get into USA JMO, how did you go about it? Okay, that's interesting. My way of going about it is very relaxed. I know a lot of people who sit at home and stare at problems for all day long. I'm not the type to do that. I have to stare at problems and I have to be there talking to myself. Oh, this problem's really cool. How about we try this? And if I feel like it, I'm gonna go take a break. It's not like other people where I just sit and I have to do math. It's just whatever I feel like doing. So, of course, the first step is to find interesting math problems to solve, and Math Kangaroo is a very good place to start. These problems are really creative and interesting, and they will grab your mind. So besides that, whenever you feel like it, go do some math. Talk to yourself, talk to friends, or search up whatever you want. Just have fun doing it. It'll be really amazing.
I just wanted to add on to that I always have my geometry book, Egmo, next to me. So whenever I feel like it, even if it's like in the middle of the night or something, I just go up and do some geometry from it. And yeah, it's pretty cool. So yeah, I would recommend make it really easy for yourself to do math. Like don't like put your books or your resources far away from you. Put them near you, near your workspace, so you can just whenever you feel like it, whenever you feel, oh, I'm in my mind to do math, you can go and do it. And sometimes your mind to do math, I don't know, it depends on you and how you're feeling. Sometimes it could be in like the morning, really early morning. It could be in like late at night. It could be in like the afternoon. But then like whenever you feel like it, you just do math. And that can really help accelerate your learnings and your fun too. So yeah. Oh, which geometry book do you have? It's the famous Evan Chen's geometry book, Euclidean Geometry and Mathematical Olympiads. So yeah.
Yeah, these are great tips. These are really great tips. I mean, it's also wonderful that you are asking these questions, because one of the fun things about having our high school stars on this show is that they can give you real tips. Oh, there are even more things. Annie, does someone want to take Annie's thing?
Sure. When studying for math competitions and whatnot, why is it a bad idea to just do a bunch of problems? I'm gonna say it's not a bad idea. This is okay, this is the mindset. If your mindset is, I'm gonna do a bunch of problems, I'm just gonna do a bunch of problems, I gotta do this, I gotta do this, I gotta do this, that's bad. But if your mindset is, oh, I really like doing this, I wanna solve this problem, it's interesting, and your mind is like, I wanna do this, then that's good. Do a lot of problems. Practice problems, on the other hand, those are a little repetitive. They're talking about one concept and, practicing one concept is bad. I was talking to someone recently. Basically, what they told me is in school, if you're taught to raise a pig, your homework, your practice problems, it'll just be raising a pig. But whereas, okay, you go into competition math or real world, anything. So if a teacher teaches you or life teaches you, raise a pig, your job is to run a barn. So that's what you want to think about.
Man, that's a great analogy. That's a great analogy. And I also want to, I also want to say I totally agree with that. And in fact, whenever I do questions, you can even see like on these questions, I get really excited when it's something that I haven't seen before. And so when you're doing practice, it's best if what you're practicing is not like trying to repeat one skill over and over again, but rather be like, I already know how to do that. I know how to do that. What's this? Let's try this. I also want to make one comment. I see that there are people, the warrior cats, actually, the warrior cats. Thanks for asking all of these questions which are coming in. The only reason we're not hitting your math question here is because that's better suited for Ask Math Anything. And that's another live stream that we run where people can ask any math questions that you have and we answer those. In fact, I believe there's a session tomorrow evening as well. But here our time is a bit too short, so we're not going to do those math questions. Meanwhile,
I just want to add on to what Aiden was saying earlier, how it's about your mindset. So a lot of people tell me like, I'm going to do all of the Ames 10 problems. I'm going to do all of the Ames C12 problems. I'm going to do all of the AIME problems. And now I'm going to be perfectly ready for, I don't know, Ames C10. I'm going to be perfectly ready for AIME or USAJM or whatever contest it is. I'm sorry, it doesn't work that way. It doesn't work that way. Like a lot of these people, it seems to me like they just want to do these problems just to be able to say that they've done these problems before. And that is not a good attitude. A much better attitude is I want to do these problems because they're cool, because they're interesting, because I'll grow from them. And so don't commit yourself to doing every single AIME problem or every single AMC or whatever it is. Don't commit yourself to that because that is like having that mindset is much more deteriorating than any amount of math like learning you might have from that, because it is much better to have the mindset of I want to learn and grow from this, and that will help you so much, not just in your math contest career but also later on in life.
yeah,
think,
this is good. Oh, go on.
Oh, I was thinking, Professor Lowe's mindset is pretty cool. He's just here to have fun, honestly. That should be your mindset.
Yeah, that's very important. And actually for me, like having fun means like thinking about a question that I don't know how to do. And I see that there's a bunch of questions which you can combine. Like Bree asked, what if it was like a practice test, like a mock test? The Warrior Cats asked, is it true you can pass the AMC by doing its past test? And the idea here is that, actually sometimes when people do the past test, they don't really do it either. They kind of set the time limit. They just do it for the time limit and they do the questions that they can do and they don't do the questions they can't do. But you actually learn by sitting there and attacking the questions you can't do. So that's like why it's better not to have the pressure. Somebody else also asked, like, should there be pressure on the practice or just like no pressure? I actually strongly believe in that no pressure is needed. You just need to go around and be like, oh, that's cool. I don't know how to do that. I also like Annie Wu. What you said is that work should be done to benefit yourself, not to flex on others. That is how we think. In fact, I have the real pleasure to work with so many incredible high school students because of what we've done here with this Daily Challenge Live. And in fact, the criteria we use for bringing in high school students is we only want the people who care about things that benefit others, not just flexing. Flexing doesn't get you very far. Okay. Ooh, got some more questions. Anyone want to hit some of these?
Yeah, so I see someone asked, only do time practices when you're already very good. I wouldn't even say that. I would say, okay, maybe if you're shooting to like do better on one specific test, like if you're like, I don't know, a month or a couple of weeks before the AMC or the AIME, and you really want to push up your score by a few points, then yeah, go ahead and do a few of those time tests. Those will actually help push up your score. But like right now, the AMC 10, I think it's like, what is that? 3 or 4 months away. If you're starting now by just doing all of the practice tests for that, it won't help you very much. Like a much better use of your time is to learn math and to grow with that. So I wouldn't even say when you're really good. I would say as long as it's not like a couple of weeks before a big test, just do things like without time limit, just learn. And then maybe before the test, start doing some of those like time tests to put yourself back into shape and to put your mind into ready into like a practice, actual test format. But when it's not in that time period, don't even worry about it. Worrying about it beforehand will just cause you unneeded stress, and that's just not helpful at all.
Yeah,
I
and
think
on the topic of stress, I saw that Warrior Cat says, how do you release stress when you're one day away from a math competition? Okay, first thing is don't stress too much. Just honestly, you're fine. You're good. If you're that worried about stressing, you must have put in a lot of work. But anyways, if I was ever stressed, what I would do basically, okay, I'm gonna make a drawing again. But what I would do is, so this is me, and I don't know, this is a day before some random competition. I go into the fridge and I grab an ice cream sandwich. And then I just sit there and relax. Just don't think about it. You're gonna do amazing.
This is very, very, very advanced advice, and also very advanced art. I love it. And also, it doesn't look like your art has been hit by a hurricane. So well done. Okay, right. With that, actually, I think we unfortunately have run right against the end of the time. So I think what I'll do is I'll just answer one last question somebody had asked, which is about Daily Challenge having organizing teams for Berkeley Mini Math Tournament or Hmmt. We actually haven't done that in the past. However, that's not to say that we won't do that in the future, because actually, as the things are going right now, we have more and more students who are joining, middle school students who are joining our classes. And as they join our classes, as we get enough people, we will certainly be, of course, sending advice to all of the people in our classes on what kinds of activities they can use to try out their new math skills. But regardless, with that, I think we've hit the end of the time for today. I hope you guys all had as much fun as we did. If you can tell, we all had fun whenever the questions were hard. And we hope that that is something that is infectious to all of you. It's much more fun to struggle with the hard questions than to feel good about doing a lot of easy problems. And we also have learned another trick called the fridge might have ice cream sandwiches. So with that, we're going to say good night or good morning, wherever you are. And we'll see you next time. There is a Ask Math Anything tomorrow evening if you're interested in joining that. But we'll definitely be back with this in 2 weeks. Bye, everyone. Take care.
Bye, everyone.
goodbye.
Maybe we'll see y'all one day. Bye-bye.